Hey guys, I'm Nick and welcome back to the new tutorial. Today we are creating a pretty complex, yet I would say beginner-friendly setup which consists of two independent techniques, and you know what? This effect and this tutorial is packed with, these little useful tricks and tips that help you when you are creating something on your own, because in my opinion, knowing how to use Houdini for visualizing your crazy ideas is not about watching as many tutorials as you can. It's all about remembering, practicing, and implementing the knowledge you learned somewhere. And that's why today we are creating this effect when we combine DOP network, Boolean, we also do some VDB displacement stuff. And initially I was inspired by this really cool DOP simulation from Hypertech. And we talked about scaling and kind of morphing the RBDs in my, that old tutorial, RBD morphing. And here I knew that we are basically scaling RBD objects. And this looks pretty cool, so I wanted to use the technique of scaling RBD, and I will show you how it works. But yeah, then I wanted to do this effect of RBDs actually filling the shape, and then we kind of use the Boolean to slice them to the precise shape. So yeah, let's open up Houdini and see what we can do here. All right, so what we will need is, of course, the GeoNode. And the only thing I would love to just copy paste from the setup I've already created is this. So those are the basic shapes we will be using to fill our tire form, or how do you call that? I mean, not the collider, but the inner part of that tire. And let me show you really quickly, because this is a box polygon mesh with 3-axis subdivisions. This is a tube with height set to 1.5 and poly extruded to 0.3. This is a sphere, type set to polygon, frequency set to 2. And here's a torus with 9 rows and 11 columns. This is a step-by-step tutorial, but I think just to save time, because this tutorial will be quite long, I will import these shapes and we can start from that. So then of course we will need our tire. So let's drop a file node, and I found this tire. I think it was free from TurboSquid or GrabCAD community, but yeah, anyhow, we can go here in the geometry file and select in our resources. You will find, by the way, two models. There's a rim and a tire. So 20 STL is our tire, and yeah, it's pretty big, so I would say we need a match size, and let's scale it down to something like, let me get this one wider, a bit wider, like 555 would be great. Scale to fit is checked, and then visualize mesh size, and boom, we have our tire. It's pretty detailed, by the way. You probably can see some sort of marks, and what's that? It's Eagle GT. All right. I see it's reversed, so let's reverse the mesh like this. Boom, works. So with this setup and my original file, which is also in my project file, so if you are multi-solver on my Patreon, you get the file that I'm creating right now, and also you get the file that I have created to demo this effect. So that file was complete mess because I was doing this for 3 days trying to figure out what's where. I'm really grateful to all of you guys that wanted to help me out in Discord. Discord user named Canada Dry actually came up with a crazy solution which involved some really heavy vex coding, but as I know, majority of you guys don't like vex that much as Canada Dry and myself, so we won't be using that much vellum here. But yeah, anyhow, the concept here, to avoid all these crazy spaghetti of the connected lines, is to use outs and object merges. And basically what I want to do is drop a null and say that for this part we are done with the tire, and what we will be doing after that, it's basically another logical block. So out tire, and you know what, we can drop the object merge actually right now, and we can call it in tire, and then we can just drag and drop this to the object. And so we don't lose the connection here, you can also press C on your keyboard and mark these with a similar color. So in my case, they will be, oh no, we have out shapes in red. So this will be orange. Yeah, cool. So let's work on our DOP simulation, I assume. So the DOP simulation consists of basically, yeah, all of our spheres, or not spheres, actually shapes, scattered inside of this tire, and then we use pyrosource spread to scale them according to the temperature. So what I can do here is drop points from volume, which will create points inside of my tire, because if I will be using just scatter, it will be scattering points on top of the faces. I mean, there won't be any points inside of the tire, and points from volume is what we need. Let's go here, and probably we'll need to do some adjustments. So point separation is set to 0.25, jitter scale is set to 1, and jitter surface, I don't know if we need jitter surface, but yeah, I don't think that we actually need it. So in my case, I was using just half of the wheel, and this was made because I didn't want to wait weeks for this simulation to be done. So let's do the same thing, but we need to make a camera that we will be using as a guide to which parts we want to delete. So right now let's drop a camera in the top level where our GeoNode is, and this camera we can set it to be 1080 by 1920 because we are posting this to the Instagram Reels, and focal length set to 125 so we don't have any you know, that distortion from the close-up shot. And let's go back into our camera, let's hit this lock camera, and let's just zoom out holding middle mouse button. And yeah, I think somewhere like this will be good. And we can also zero out angles of the camera, so 0 on Y, and I think, yeah, 182 is how much we went to the left side. You know, yeah, I think we will be good. Now we want to delete all the points that are not in the frame. So let's go and drop the delete node. In the delete node, I want to hit on this bounding volume, and we want to delete points, so entity set to points. And from my previous project, I know that the size should be 3.1, 10 on Y and 3 on Z, and center should be -158. Yep, look good. Alrighty, so now we will be creating our burning group. So I want this group to be the group of points, and I want to call it burn. And then we will need to also create this bounding group of points, and I can use bounding sphere here, and the size should be 0.7, 0.7, and 0.7, and center should be 2.8, 0, 0.2. And you can see that we are just targeting this little blob of points here. Then I want to drop the attribute wrangle and create my attribute, and we can plug this burn into the first input, run over points, and set the temperature to be 1. Right now I'm setting temperature for all the points, but I don't want to do that, so here in the group I can set it to be only the burn group. Alternative way to doing that would be attribute create, and here I can name my attribute temperature in group burn and default 0 but value 1. This is absolutely the same, I just lower wrangles somehow. And now pyrosource spread is what we will be using to spread the fire from our burning or our hot points here. So we can set the visualize to be temperature, and right now if I click on visualize, you can see that we have a little blob of hot points here, and cooling rate should be set to 0, rate should be set to 5, search radius, in this case I'm using 0.16, and max neighbors set to 10. If you are using less points that I'm using here, so your point separation is higher, actually, you will need to maybe set the search radius to something a bit more, because if point separation is more, actually, than search radius, then it won't work. And diffusion noise, I would like to keep it at simplex, but set the element size to 0.2. And now if I play this pyro source spread simulation, you will see how our temperature changes, and yep, good. Takes us 160 frames to maybe more, 180 frames to actually get this all flaming hot. All right, so now it depends on what kind of Ryzen Threadripper you have, right? So I'm using delete node here again, because this amount of points was way too much for my laptop. And I mean, I wouldn't have patience to actually wait like 4 hours for the cache. And despite this is not the heaviest project I've done, but for the tutorials, I really like to get, you know, kind of the median between is it looking good and is it crazy hard to simulate. So this, after our pyro source spread, because I don't want to manipulate these search radius things, I want to actually delete a few points. So let's drop this delete. Entity should be set to points, and here's the random tab. You can enable that and you can delete. I think I deleted like 20% of the points. Here you can see it, pyro source spread, we are having 90,000 points, and in our delete we now have 72. And 20,000 points, it's not that much, I would say, but I would encourage you to experiment with this delete node, because it's fairly simple and easy way to do some experiments and without actually worrying about adjusting the parameters of your pyro source spread. All right, so now we wanna drop the object merge, and now we wanna copy some of our shapes, or actually all of our shapes, onto these points. So our object merge needs this out shapes, and you can see out shapes is red, so we wanna colorize this one object merge into red and call it in shapes. So now I drop the connectivity. Oh, and actually I forgot to tell you about these shapes, right? So for these shapes, what I've done is I add the auto UVs, essentially the UVs, and then I created this attribute called shape. So shape 1, you can see the value 1, and class set to primitive, type of the attribute is integer, and this is very important. So class 1, second object has the class or shape actually 2, third one value 3, and fourth value 4. And then we merge them all together and drop this out shapes. Sorry for the confusion. I was just really wanting to start this tutorial, so I forgot this little thing. But yeah, now we can continue. And after this object merge, which brings all of our shapes into one blob of something, we just drop the in shapes, and after that we drop the connectivity. And here we can use, I don't know, word type. We don't want to use the same shape attribute, but yeah, type works pretty good. And then we drop attribute from pieces. If you are familiar with that, you already know that we will be kind of iterating randomly, iterating through our shapes and spawning one of them to the point. So this delete node goes into the right input where it says point cloud of the attribute from pieces. This connectivity goes into the left input geometry library, and in our attribute from pieces, piece name should be type, or yeah, type, and mode should be random. Now we drop copy to points, and this point cloud goes into the left input, and this connectivity goes into the right input. And now if I copy all of these to points, it will take some time to process, and you can see we have a lot of geometry, and it's very hard to actually like navigate the viewport even. It's really glitching. So we definitely want to defreeze the p-scale and also maybe randomly rotate them. So Yeah, let's do that. So what we can drop is attribute wrangle, and let's drop it here, and let's visualize it for now because we don't want everything to fucking freeze. So normals should be result of random function based on point number, and our p scale should be something like 0.01. And then in attribute from pieces, there's everything correct. For the copy to points, I want to check this piece attribute and call it type. I want to call it type, same as connectivity and attribute from pieces. Now, if we visualize the copy to points, we will see that, yeah, I think it works. Yes, it is. It's all red because we have the pyrosource spread set on temperature visualization. If we set it to none, you can see nothing is red anymore and all is good. All right. So after copy to points, you can set this back an instance here, but I think assemble node actually adds some sort of name and you can transfer attributes. So let's use assemble node and let's visualize it and select create packed primitives. And we also want to transfer attributes, and the attributes we want to transfer are temperature and shape. All right, so now these attributes, temperature and shape, are actually transferred to the points because now each of our packed primitive shapes, each of our cube, torus, sphere, and this little tube are represented by the points, by the corresponding points. And now we can create some .NET information that will be needed to simulate our object growth. All right, so let's go and drop a few attribute wrangles. So this one will be about particle growth. Let's call it p-scale animation. And now I wanna set the p-scale to be clamped value of the temperature. So fit requires or takes the value in one range and shifts it to the corresponding value in a new range. So technically we could just go some value, I don't know, and we know that this value goes from 0 to 10, and we want to shift it to be 0 and 1, for example. And this will shift, for example, if the sum value is 5, it will be 0.5 in this case, in this scenario, because we are shifting from 0 to 10 to 0 and 1. But we have temperature because we passed it through the assembly node. Here we have transferred attribute temperature. Now here we have, oh, come on. Now here we have the temperature on our points, so we can bind the p-scale on it. So p-scale equals fit at temperature. And I know that, you know, of course temperature is always rising, right? But you can experiment with that. And this was in my VDB morphing, I think, VDB morphing, where we were kind of morphing not the morphing, but kind of growing the case or the frame of the watch, and I encourage you to play with these values from 0 to, you can go with 3, 10, 15, whatever. But the thing is that I found that 0 and 5 works pretty well for this scenario. And with the .NET, as with the Vellum, actually, you cannot go like 0 in p-scale because it will glitch. So we want to go with pretty low value, and I will explain how we will mask out these low p-scale value objects. We will just delete them. So we are shifting range of temperature being from 0 and 5 to starting from 0.03 to 3.2, all the way to 3.2. And then I want to introduce some random. So p-scale plus equals, so we are adding to the value that we have right now. And here we just use our fit01 random based on the pt num, and then 0 and 0.2. So we maybe will be adding something between 0 and 0.2 with a probability of random. So this is our p-scale animation. It's done. And now let's go and create some DOP network constraints. If you are familiar with Voronoi fracturing, I mean this Voronoi fracture or RBD fracture, whatever, this SOP node actually creates these constraints for you. But here we are creating constraints which are essentially polygons. We are creating them at the point at the center of our shape. So let me show you. We will need a few attribute wrangles. So this one, let's call it ID. I think some time ago, and it was a pretty long time ago, I initially found this on CGWiki or some Altforce forums. I'm not exactly sure, but it was that time when I was like, oh, so these constraints are the same type of geometry that my kind of any other regular geometry is, right? So here we are working only with this geometry that we have here. So we are adding to all the points, we are adding the ID, which is the point number. And then we drop another one, another attribute wrangle, and we set its name to be blank for now. And then we want to merge these two together, and then we drop the add, which will create that polygon that will be representing our constraints. So let me drop this add here, and then let's go inside to the polygons tab. Remove unused points should be checked, and we will be creating these polygons by group. And add should be set to by attribute, and attribute name should be ID that we just created a few wrangles back. And now we can finally create the type, the name, and other parameters of our constraints. So attribute wrangle again. So our string variable constraint name should be pos. Our string variable constraint type should be position, because it's position constraint, and rest length of the constraint should be 0. So rest length, yes, 0. All right, and here we are ready for the DOP network. The only thing I would love to do before going to the DOP network, I want to increase the percentage of the points that we actually delete to like 60, for example. Because just for the demonstration purposes, I want my simulation to run pretty fast, so maybe even 70% of the points we will delete. So we are ending with 27,000 of these little packed fragments of, or actually shapes, right? Shapes. So let's drop the DOP and plug this attribute wrangle to the second input, plug this first one to the first input, and then let's go inside and arrange our simulation. So what do we need here is, of course, go back to the frame 1 so we don't accidentally cache out, try to cache out to RAM 180 frames. But RBD packed object is what we need. We set it to be create deforming active, I assume. Geometry source should be first context geometry. Override attributes, we override the p scale. For the bullet data, I think it's all default here. And for the physical, we wanna uncheck compute center of mass and compute mass. We actually don't need mass, right? In the bullet data, we actually don't need collision padding, and shrink collision geometry also should be 0. And yeah, I think we're good with our RBD packed object. Then we drop the RBD, or no, rigid body solver, rigid body, and connect the RBD packed object to the first input. And here in the rigid body solver, what we need to do is up the number of substeps to something like 25. Sleeping time should be 0. Ensure islands are independent. Let's uncheck that. Constraint force mixing, we can leave it at 0. For the RBD, nothing, and fracture, nothing, and yep. Should be good with all the things here. The only thing we can add is pop drag and set it to something like 3, pretty high value. Let's test it by adding gravity and connecting the rigid body solver to the gravity. And yes, we have our objects. Let's test how fast it actually can go. I assume not that fast. Detecting collisions 2, then let's go to the 3. And but yeah, they are falling. Definitely they are falling. Let's just for the sake of time, cancel this simulation. We see that everything works, even the p scale works. Let's go and set this end frame to be 180 and this 180, so we have just a bit more precise control over the frames we see here. And just by scrolling these frames, you can see that we are falling actually, so everything kind of works right? So gravity, we don't need that. We just need to add the constraint network. So constraint network goes here. You plug that in between of the rigid body solver and your out. And you see now we are hooking the DOP. We don't need that. Let's go back to the frame 1. For this constraint network, we need to add constraints we will be creating. So, and we want these to be spring constraint relationships. And right now, we just want to connect the spring conrel to the second input here. And let's go check what we have in this new node. Here, strength, I want to set it to be 20. Rest length 1, damping 20, and data name should be the same that we made it in the attribute wrangle, so it should be pos. And our constraint network actually should not be some sort of a sub. It should be the second context geometry that we created. This whole setup with the constraint network, I will try to find this example from CG Wiki and I will link it down in the description of the video so you guys can get the file and play with these different constraints. So now if I go to the frame 2, and I don't know why, but in the frame 1 it's not the correct p scale for our objects, but on the frame 2 it's kind of the correct one, and you can see that our objects went smaller in size, but we have correct p scale, at least now where the temperature is not that high and the p scale is also not that big, but you can see that this blob of hot points is actually bigger than all the other ones. But you can see that we have the error on the constraint network and it says required attribute constraint name is missing. Let's go back to the geo and our attribute wrangle and see constraint name, constraint type. We have it. Oh, it should go over primitives. Yep. Now if we go to the DOP network, and yeah, here it is. So these are the visualizers of our constraints, and let me just set it to be, the radius set to be 0.001, or actually 001. And for this, just to visualize it, I want to drop the gravity, and let's go to the frame number, for example, number 6. So here's what I wanted to show you. You can see that these lines are created to visualize our constraints, and because they are spring constraints, they will actually try to, because right now we initiated the drop, but after these constraints stretch out to their maximum, they will try to get all of these objects back up. And this is what we want, but just without gravity. And because we will be increasing the p scale and they will collide with each other, but we don't want them to fly away because of the pressure between them. We want them to stay in place, and that's why we are adding these constraints. So now we can try playing that. You can see, yeah, these are the constraints, all of these yellow little yellow lines you see there. And yeah, let's remove the gravity, and basically our RBD setup is done. After that, you want to drop the file cache node, and in my case I want to get these to these 20%, not 70. I mean more points, more objects, more fun, more simulation time. And yeah, you just want to go and file cache 180 or 160 or whatever amount of frames you want. I mean 180 because we have our pyro source going to 180, and I have my caches from the previous, from my demo project, I mean, and here in the file path we can go explicit, and in your case you want to hit save to disk and go for a walk, go for a gym, I don't know, go grab a coffee, whatever, depends on your CPU speed. In my case, I can just go here and select the RBD morph scale file cache, and I will have it all cached out actually. Again, first frame is not the correct one, but oh, nope. I should have checked this load from disk. And now if I scroll it, yeah, now you will probably see how they should grow. Yep, you can see right now we are getting these from the file cache. This is a pretty big blob of scaled objects. Let me run a flipbook so you can see how this animation should look like. Let's go here on the flipbook with new settings, and here frame range 0 and 160, and flipbook size could be 1080 by 1920, and hit start. So here, a quick preview of the animation. You can see a little splash right here. You can see these particles were growing too rapidly, and of course we are getting these splash frames because the simulation or the flipbook is going right now. It's calculating the frames, but essentially, yeah, this is how you should see your simulation when it's done. We don't see a lot of intersections, the geometry is clean, and you see there is this nice, kind of wave effect, and you couldn't get this just by spawning the objects and not running the DOP simulation, because here it really looks like a wave, and you see the interaction between the objects. So that's why this is important to actually run the DOP simulation. And I know it's slow, I know it's like really slow to simulate that much objects, but this is essentially what Hypertech did here in this video. He just scaled a whole bunch of objects, sorry. So after this file cache, we can drop another null and call it out dop sim. Let's colorize it to be purple, and let's drop object merge right now. Drag the out dop sim into the object one, and let's call it in dop sim. And for this one, we want to get it purple as well. All right, looking good. Just want to arrange these like this, our DOP stuff here, and we are ready to work further on the Boolean part. So let's drag our in DOP sim somewhere here, where we don't mess with this part. And yeah, so now you can see that we have a few points that are super tiny. We don't need them actually. So let's unpack our geometry from our DOP simulation. This unpack will have all the necessary attributes, groups, whatever DOPNet creates. You can click on like visualize the unpack, so it actually cooks, and then on this I sign you can see we have all the attributes we will need. Now we can delete all the small parts. Let's call this group small parts, small objects actually. And now I want to drop the delete, or actually no, in this group we want to of course write the condition to detect these small objects. So I know that the temperature, or actually p-scale, is bound to temperature. So we can target all the points that right now are have the temperature less than 0.1. Let's visualize our group, and yes, we can see that all of these points actually they are cold. We don't like cold. Let's delete the group cold. Oh, come on, no, we just want to type small objects, entity, points, delete selected, boom, they are gone. So now the fun part begins, and this is actually using the booleans. So to make the coloring of objects possible, we need to separately boolean them to our collider, and that's why this will take even more time to process. But still, it just depends on the amount of objects you use, right? If you use like 10,000 objects, it will be fast. If you are using, like I was using like 70,000, it will be slow. But anyhow, let's start dropping our groups. So this group is called shape1, and group type set to be primitives. Base group should be bind to the attribute of the shape, because as you can remember here, all of our shapes have their attributes 1, 2, 3, and 4. So here we can write @shape equals 1. And this is our shape1 group. And then we drop a delete node, and we delete everything, every primitive. These are primitive groups. We delete everything that is not in our shape1 group. So not delete selected, but delete non-selected. And if I visualize this delete, you can see right now we have only cubes left here. And then we drop the boolean, and we plug the delete into the left input. So into the right input, we wanna add our tire, but to make it more precise, I think we will need to VDB the tire. But let's try right now object merge without the VDB part. Let's drop this out tire into the another object merge. We can see the out tire is orange. Let's colorize this to orange and call it in tire. Let's plug it into the boolean a, and for our boolean we want to go set a resolve self intersections actually, and operations should be intersect. So let's see what we got. I don't think that this is what we actually want to see. Yeah, you know what? We will need to VDB our booleans. So yeah, after out tire, let's drop VDB from polygons and then convert it back to the polygons. So VDB convert, and let's call this one out VDB tire. Let's colorize it green, and for the VDB from polygons I want to go with a pretty low number, around 0.01. Yeah, this looks pretty good to me. Convert VDB of course should be set to polygons, and yep, this sounds good. All right, so this object merge should actually be merging our out tire VDB tower, so it should go in VDB tire, and also we want to colorize it to green. And now if we go into our boolean, it will take some time to process because we have a bit more polygons than the previous version without the VDBs, but I think the result should be, yes, it's much better. Now you can see our cubes get that cut, but it's not cutting them inside, so we have our cubes as they should be. One thing we could do here in convert to VDB, no, in the convert VDB, we can set the adaptivity to be 0. I don't know, 0.4 maybe, yeah, or nope, maybe, yeah, 0.5 is actually okay. So maybe it will make the boolean run faster, just a bit faster. Yes, it is. So I don't think that it influences the result, but yeah, you can just play with this adaptivity. But the problem is that right now the boolean is generating new faces. You can see them here. You can see that they don't have UVs. That's the first problem. And for now, I don't know the possibilities of like how to add the UVs back to these shapes. So that's why I actually just colored them. I haven't applied any sort of, you know, the displacement material or something to my shapes. And unfortunately, I wasn't able to solve this issue right now. And you can see that we still have our attributes, like our shape. We still have it on these faces, but we don't have them on the newly generated by Boolean faces like this here. So we will need to again go, actually we can just, yeah, go here, copy this one, attribute create, and drop it here after the Boolean. So unfortunately, that's the only way around to get these shapes in form of our collider. This is really slow to simulate. Maybe you want to go with some static frames first, but still, it's a good to know technique, I would say. And then you copy these 4 times. Just rename the groups shape 2, shape 2, shape 2. Then again, this will be shape 3, and shape 3. And once again, this one will be shape 4, and deleting everything that's not shape 4. In the attribute create, the shape should be 2, shape should be 3, this one should be 4. All right. Then we gotta merge all of these into the one single object, because right now if I visualize this attribute like less in the chain of everything that's about shape number 2, which I think is the tube, you can probably see now that we will have only these tubes here. Yeah, all the tubes, you can see they've been cut, but you can see that they perfectly follow the shape of the collider. And I really like this effect. It's like, you know, if you glue all of these objects together and then you just kind of, you know, polish them, or like with a sandpaper you go and shape it all, like if they would be with that clay, or how do you call that? But yeah, anyhow, let's check how it looks all together and with that boolean cut. Right, it took some time, but yeah, here you can see it's really beautiful. It fully resembles the shape of our collider, our tire. So yeah, after that, you drop your normals, because I don't think that we have them. Yeah, we don't have the normals, but we should have them. So drop the normals, and you're gonna file cache this one. This will be pretty long, and yeah, in my case, I already simulated 160 frames. So this one, I want to set it again to explicit, and this one should be my, let's go here, it should be my geo final. So this one, and I want to click load from disk, and right now I can go to the frame 150, and you will see that we have at least half of that tire simulated, and we have all the ridges, all the dents, everything is there. Now I can apply the material, and yeah, let's set it up. Just wanna rotate it a bit, like this, like I have it in my demo. And yeah, let's go set up the lights, materials, all of that stuff, and then we will continue with this black paint thingy. So what I want to do is drop the RS light dome. Let's go check my resources folder. We have Brown Photo Studio, saturation set to 0. We don't want to be a background of our environment, and enable viewports also should be unchecked. For the transform, just want to rotate it -15 on y-axis. And yeah, now we can drop new paint tab type, and let's save the project just for the sake of, let's just be safe. And new pen tab type, redshift, render view, and let's fire up the render. And here we have our beautiful shapes. Just look at them. Let's set up some materials to work with. Let's drop RS material, and let's drop redshift material out node. Let's connect out color to the surface, and let's call it type 1, and we will be copying this 4 times, and it increments itself. So just for now, let's set it to be red, another one to be green, third one to be blue, and fourth one to be this pink. Let's go back to our geo, and here in the materials, I want to create 4 materials. So 1, 2, yeah, it lags a bit. So let's pause the redshift and add 4 materials. So our groups are basically our types. So our shapes actually. So here I can go and write at shape equals 1, and then pick the material from my network type 1. So here, let's duplicate that, shape 2, shape 3, shape 4. And same for the materials, type 1, type 2, type 3, type 4. Save the project, visualize the materials, hit play. What an acid mess. So I was experimenting with different kind of colors for this effect. What I want to do is, first of all, make them rough. This will make these ridges much more visible. Probably I will need to restart the render. Yep. So now for the colors, I'm using sort of dark tones of all of these colors. So for the material 1, I'm actually using pure black. I'll get back. For the material 2, I'm using this like very dark green. Oh, this one looks cool. Look at that. But yeah, I was using, for the material 3, I was using this also sort of green. And then just one material was a pretty, like, compared to others, was pretty bright red. And I want you to just compare how these ridges are visible when the roughness of these materials are set to, yeah, something like 0.1, and you see it's much less visible here. But once I set it to be like 85, 0.85, it's much more like a, you know, rough plastic the look that we are going for actually. Of course, we will add post effects and all that stuff, but this already looks pretty cool. So now we are ready to go and create this spreading rubber effect, rubber growth effect. Let's go back to the scene view. Let's go back into our geo, and we will be working with this out tire. So let's drop two object merges, two of them. We want to drag the out tire to the object one. Let's call them in tire, again in tire, and this should be yellow, or no, orange actually, or whatever this color is. So we want two things. We want some points to spread our pyro source, and second, we want some VDB to then transfer the temperature attribute and do something cool with it. So let's start with VDB. So VDB from polygons, drop it here. What a mess it is here. VDB reshape SDF. Yeah, let's actually go one by one. So voxel size here should be pretty low, so 0.07 or actually 0.07. Yep, good. For the VDB reshape SDF, I'm using dilate and offset is set to 1.7. And you can see right now it's already looking pretty good. Then just to smooth out VDB, nope, not the VDB morph, VDB smooth SDF and aberration. Here I think I'm using mean curvature flow and duration set to 4, and then convert it back to the polygons. Convert VDB. VDB convert to polygons. Look how dense it is, but it's all good. And now let's work on our pyrosource spread. So what we want to do here is essentially just copy our previous pyrosource spread. So this one. Just Control C, Control V, and then plug it here. And the only thing I want a lot more points. So right now we are using 0.025. 0.01 is what we maybe need. So then delete part of it, then again group the burning points, then again make them have the temperature at 1. But this pyrosource spread, I want it to actually be pretty fast, like a bit slower than we have our mesh, our objects growing. So let's visualize the temperature and let's see that it's super slow. At frame 17, you can see this is only the area that is burning. And if I visualize this pyrosource spread at frame 17, actually, you see that it's a lot bigger blob. And it's correct at frame 17, but for example, at frame 45, you can see this blob is here, and pyrosource spread, which is like our high res spread, it's only here, and I think it will be a big difference between how fast objects grow and how fast that VDB thing grows. And I don't want this gap to be too big. So for this pyrosource spread, what I will be doing is I want to set the rate, I want to animate the rate. So at the frame 1, it could be 5 and it's fine, but at the frame 90, I want it to be like 30, and I want it to really kind of spread out, you know? Everything else is default because I want this pyrosource spread to kinda mimic the way our object scaling is spreading. So that's why I drop in a file cache node, because this one takes time. It's too many points to be simulated in real time in the cache, in the RAM cache. So 160 frames again with explicit time cache, or not the time cache, the geometry path should be explicit. And then you drop your, in my case, I have it, but you just click save to disk. I will click load from disk. And now you will see that I have it already done, this burning effect. So after this file cache, I wanna create an attribute. So attribute wrangle, I'm using wrangle, and here I will need to create a custom attribute, which is essentially a remapped temperature. So fit temperature 0. In this case, I want to set the range for the input value of the temperature attribute to be from 0 to 10, and the output values should be 0 and 0.25. And yeah, this is just a remapped temperature attribute. And then I want to drop a color and just want to visualize the temperature. To visualize the temperature, to visualize any sort of color, we should turn off the visualization of the pyrosource spread. And now let's go to the color, ramp from attribute, temp from 0 to 0.25. Now let's drop the color and boom, looks pretty good. And now we can also see how it spreads out. Yeah, looks pretty good. What we want to do next is transfer these attributes to our VDB mesh. So attribute transfer, boom. Let's plug this geometry, or actually our points, let's plug them to the right input geometry to transfer attributes from, and convert VDB to transfer attributes to them, to the VDB. Now this attribute transfer, we just wanna color data and temp. And the conditions here, I think we can set the blend width to be 3, although I don't think that it actually makes, yeah, it doesn't make any difference. But yeah, anyhow, what I want to do is blur the color data just a bit. So attribute blur, attributes that we want to blur is CD, pin border points unchecked, blurring iterations 20, just a bit of blur to remove this stepping here. And now, interesting thing with this noise effect that I have, just on the edge we start to see like when it grows. So what I want to do is blur a bit this whole geometry. Let me just bypass the color node for now, so we see full mesh in one color. So after the blur, I drop another blur, and this one should be set to P position. Blurring duration set to 50, and pin border points should be unchecked, and influence type set to proximity. And now you will see how this gets, yeah, blurred. Cool. Now I also want to drop the mountain node and let's visualize it. Let's see this awful noise and how we can fix that. Range values, min and max. So here min value is 0, max value is 1, already looking better. Element size 0.3, max value at 0.1. And yeah, this looks much better. Now I somehow wanna morph between this state and this state. How we can do that? Using blend shapes. We could do this linear interpolation the wrangle as I usually do, but I think we have actually enough wrangles in this project already. So drop this mountain node into the first input and your regular tire into this kind of multi input. And let's move the attribute blur mountain here and blend shapes. Here what we're gonna do is blend masking set it to be set from attribute, and blend mask attribute should be CD. Now if we visualize it, nothing happens because we haven't set our color data, which is here. You probably could use the temp attribute because color is essentially temp. So let me just prove it. Temp. Oh, somehow it doesn't work. Let's use the CD. But essentially, drop a normals, because we don't have normals, I assume. Yeah, now we have here normals. And drop your material. And this is all about the material here, because we will be controlling opacity, we will be controlling roughness, we will be controlling a whole bunch of things here. Let's go to the redshift render view, and let's go to the material network. Oh, of course, let me just assign the material. So this one will be rubber, or actually tire material. And let's go back to the geometry and set it up material, tire material. Cool. Save the project so we don't crash and lose all of our data, all of our sweat and tears we put into the scene. Let's go material network and let's start building this pretty complex material, I would say. So first of all, let's see how it looks right now. Looks pretty awful, I would say. First of all, the color. Let's set it to be sort of an off black color. Then I see that we definitely should add the opacity, because right now it's just something really weird. I don't get it. I don't get it right now, but hopefully if we drop particle, nope, RS particle point attribute, but it's called particle attribute lookup. And then we plug our color into the opacity color. Now we probably need to restart the render. Yeah, now it works. But this opacity doesn't look quite right to me. It looks like a fade, and we are not doing any sort of fade effect here, right? So we can drop the RS ramp here. And now I want to stop the render for now so I can make these adjustments quicker. But essentially what you want to do is set these two sliders around here and around like close to each other. Now if I play the redshift again, redshift viewer again, you will see that this border here, yeah, look at that right now. So this is much more crisp, looks much more like an actual growth effect. And you can see it starts, it has this kind of mountain displacement here. So again, what we can do now is I want these displaced kind of liquefied or not yet solidified parts. I want them to be much more rough than this part, which is kind of solidified. What we can do is drop the, again, particle attribute lookup, just hold Option, or on Windows it's Alt, and drag, and boom, you copied that exact same node. And let's attach it to the reflection roughness and see what we got. And this already looks much better. The only thing I want to do is add a bit of variance to this. So let's go and drop a max on noise. And because we don't have UVs on this VDB, but luckily it stays in one place in our screen or in the 3D world, we can go to the max on noise input tab, and source of the noise should be world, and then it won't be flowing, you know. For the max on noise, I will be using turbulence, and this turbulence octave set to 10. We can visualize it by plugging this noise to the diffuse color, for example, and here you can see our noise. I want to adjust the brightness and contrast, so set the brightness to be 0.084 and contrast minus 0.524. So yeah, pretty rough. Don't want to be like too crisp, too detailed. It's just like a wear and tear thing for our roughness here. But the main thing is, again, I want to go with RS ramp. We will add that later. RS color composite. I would say this is what we need. Let's drop it here. Base color is our particle attribute lookup color, and this max on noise goes into the blend color. We can probably right now we won't see anything, but let's cut these parts off, and out color goes into the diffuse color just to visualize it. So now you can see that we kinda have this effect here from our particle lookup, but for the RS color composite mode, I want to set it to be subtract. Yes, this is exactly what I want. Let's preview that on our roughness. So cut the diffuse color link and add it to the reflection roughness. Yes, this is exactly how I imagined that. This liquid rubber thing on top and the bottom as it grows. Really cool effect. The only thing is RS ramp. I want to add it here. Post the redshift for now. So yeah, again, just a bit of the remapping in the roughness settings like this. I think it will be fine. Let's play and see if we have any changes right now. Yeah, I think this looks a bit better, if it even differs. Yeah, I think so. Maybe we can also add sort of a bump map, because why not? Let's drop in the max on noise. Don't forget to set the input to be world. And for this one, I will be using FBM noise with these things here. Set to default overall scale 0.3, and then drop RS bump map, and let's plug it into the texture input, and this bump map goes into the overall bump input. And let's just see how strong this bump map is. And yes, it's definitely too strong. So this height scale in the bump map should be 0.001. Yeah, this looks much better. We have subtle bumps, but not too much of them. This is with the bumps at 0.01, and yes, it's definitely too much, so 0.001. Yeah, all right, so now the only thing we need to do is to actually merge these two together with our where it was with this RBD morph file cache node. So let's drop a merge and let's drop this one here, this one, save the project right now, save the project, this one to the merge, visualize the merge, and hope for the best. And yes, it works. Looks pretty good to me. Looks very, very similar to what I've done in my demo project. Again, post effects, a bit of color controls, a bit of exposure, maybe a bit of contrast, photographic exposure. I don't think that we need that, but yeah, then just add a bit of bokeh, animate the camera, I think, and you will be good for the bokeh. Aim for somewhere here, as I did, and let's go to the out. Redshift drop. I'm using camera 1. Output should be, I'm rendering PNGs, I'm rendering EXRs. For the redshift, don't go with the basic controls, go with advanced. And automatic sampling, I usually set this to be minimum samples to be 16, max samples to be 512. For the reflection, I override it to be 512. And for the light, I also override it to be 512. Threshold, I set to be 0.003. For the globals, global illumination, 10, 10. Both of them brute force. And yes, that's it, guys. Right now, unedited version is 1 hour 48 minutes. I will do my best to make it. I hope so. It will be like less than an hour or so. But I really hope that you enjoyed this tutorial. I was working all of these days, all week, days and nights to get this result. And I really hope that you enjoyed it. I think this is by far most, packed with these little tricks and tips and like everything, the best of my tutorials. And I really hope you enjoyed it and found a lot of new useful things. I will be back next week with a new tutorial. Bye!